So, hello, thanks for coming. So you're gonna kick off with the cell-based architecture. It's now a lot of people write about it, but it's actually quite old. So I thought that maybe we'll discuss this bit first. It's nothing specific to Go. It actually is very generic to building services in general, like whatever languages, whatever technology you use, doesn't matter. Maybe a little bit about me. I'm doing it for a long time now. Not super long, but quite long. And I'm building a storage as a service here right now at Pure. I'm doing, well, I've done DevOps before. It was cool because my career started as a on-call engineer for cashier systems in like Tesco's. So, and there was a lot of DevOps stuff in there. We just didn't call it that the same at the time. So, starting with that, what I'm going to cover is like how it actually evolved. What was the problem? What problems it solves? What is it? Like how it works, how to apply it, how to use it, and how it actually relates to microservices, because a lot of people might feel that it's the same or similar. So maybe like, what is the starting point? Like, why even like someone can come up with this idea? So, usual service in the web. That's like, this has been going on for like last 25, maybe even more years. I remember doing that in 2001. So that's good. Very simple, easy to use. Doesn't matter if you use Kubernetes or not, like whatever VMs, you can run it like in whatever way, right? But it's basically the idea is your application runs, that's the process, and there's load balancing between it, and you have all the storage in the database. Simple. Now, that's simple, but if it starts scaling, let's say it takes off, right? Like a lot of people, oh, I now need a lot of web servers. Oh, they just solved only the part like authorization, handling the basics. And then I have more components. I need to load balance between them. And they have interdependencies. And I need to make sure that I don't break things. I roll out safely, right? There's a lot of things. And now I have maybe database, and I have a primary and a secondary, and maybe read replicas, and maybe cache, and I don't know what else. It becomes really complicated, right? There's a lot of challenges in what to do with this. You cannot only do this forever, right? I worked on a when I was in Oracle doing Oracle Cloud Infrastructure. This part had 100 machines, right? It became really hard. It's like, yeah, you need to grow 2x, 10x. It's like, it's going to be 1,000 machines. It's like just too big. It becomes impossible. And then you have all the load balancing in between. It becomes like basically impossible to move on. What are the challenges, right? It becomes totally impossible to test. Like, how do you test these? Like even you don't do this in Docker Compose. You just don't. You hit all kinds of scaling issues, right? You get practical size limits, right? Like how big the database can be. If it becomes petabytes, it becomes basically unusable, right? Practically speaking. Also, with all this, if you have a customer which has like really strange behavior, users, they can basically kill the system in some way, right? You get like noise neighbor problems. You have to somehow isolate this. It's really hard. You get, if the system is really large, you get like nonlinear behaviors, right? Like, oh, you scale linear, and at some point, let's say 50 machines, all of a sudden, you get like super crazy latencies. Oh, because there's like cascade of calls that actually cause, they throttle somewhere and propagates through the system, and you're lost. I experienced that. It was really horrible, close to impossible to find out like what is going on. Deploying this stuff becomes super hard as well, right? Especially if for example, you have like a lot of dependencies, and the last one is the one that breaks, and you have to roll back. But he introduced a lot of changes along that way. You're gonna spend days rolling just this change back. And hopefully, you hope it works, right? Or you're gonna like roll forward and have an outage for 2 hours, 3 hours, 5 hours, right? I covered the rollbacks. And worst case, the nightmare is that you can really break it so that actually everything goes down. Like there's no isolation. It's unlikely if you're really careful, but it can happen. So what's the big idea behind this? It's quite old. I learned about it in 2005 or something. So it's not something great, but what do you do when the database gets too big? Shard? Yep, good idea. Sharding. What if I do the same thing, but with the whole service? You see? It's genius, right? Like that's the idea. You shard the whole service. Forget about everything else. This is easy. So that's the idea. You take the thing you have, just replicate it 5 times. There's some magic sauce in the routing. It's called cell router, and this is the cells, right? The cell is actually the small practical thing you can work with and easy to maintain, right? Nothing, you want to keep it fairly straightforward, whatever it is. It does not have to be like as simple as this. It could be more complex, but it's a thing that you can easily maintain, right? And then you have the decision, the routing should be simple, right? Customer ID or whatever. So, and what do you get by this? You can test just the cell, right? Like you don't have to do anything magical, and you can have the cell fairly small. It's like a load balancer, 2 machines, database, good. Docker Compose works. You want to scale a lot. They have more and more cells, right? And you can scale also the cells inside, right? Like it does not mean that a cell is one size fits all. No, I can make it. I can start with a load balancer and 2 web servers and a database, and I can maybe, I know that it's behaves nicely. All this would I have 10, 15, 20 servers. It's good. And then I say, oh, I'm reaching the limit. I have to get a new cell. Do I have like a super large customer that's going to kill me? Oh, I'm going to give them 1 or more cells just for them. It's like easy. You isolate them as well. If you deploy something horrible, if you're clever, you're not doing all the cells at the same time. Yeah, you broke 1 cell, which is bad, but you're always just that one small thing. You don't have to go through all the horrible mess. It takes forever because it's super large. You roll out in some clever way, you validate in a couple of cells and say, you know what, I'm going to do 5 cells at a time, speed it up. It's actually really hard to break this completely. The only place that actually is possible a single point of failure is the cell router, right? So that thing you want to keep is like super simple. And even that can be solved by, you can make it, the router could be also like HA, and you can do a lot of things. It doesn't have to be like a 1 VM, right? It could be a load balancer with 5 VMs again. So you can make that even quite clever as well. Now, the question is like, how do you start? It looks quite complicated. Actually, it's very simple. You take what you have and you say, this is the first cell, I'm done. And then just replicate the thing. Maybe you need to do some cleanups and you want to make sure that you don't mess it completely and want to isolate, but essentially that's how you start. So the only thing you need to do is introduce the cell router, and actually the cell router in the first part does everything. There's just 1 cell, so I'm not clever. And that's it. And now you can make decisions on other things, like how do you build the router, like what it should be. You can go old school and say like, oh, it's going to be DNS. That's one of the oldest patterns, right? Like, for example, if you use Slack, you get a different domain name. That domain can be different cell. You can have your own cell. right? The only thing you want to make sure is you have short TTL, because what if you need to change, right? That's one option. Other is you have a dedicated service that actually does a HTTP redirects. Again, nothing super clever. Maybe you have a simple database where you basically have a mapping, customer ID, whatever ID you have, maps to something, and you redirect on that. If you're in cloud, you can use API gateway, or you can run on your own, and it depends what does the gateway support, but there's a lot of options you can do. Now, how to map the users, right? Like, again, all the usual classic partitioning schemes might work. Whatever you come up with, like the basics. Customer ID, hashing it, consistent hashing, all these options work. You can go and have like directly use 3 cells and just like assign the same way you do load balancing. You can assign it to least utilized cells. You say, oh, this one is empty, we can throw in more people, right? Or, for example, some of the companies, they use geographically based cells, right? So they isolate customers from different countries and basically separated by that. Sometimes it's useful because different rules apply, right? So, for example, you know, like Europe is way more stringent than other countries in a lot of things. So that might be a good reason. You can also, that's another useful thing that a lot of companies use if they use cell-based architecture, is they have customer tiering. You're not paying. You're probably in the worst place, right? It's going to be the overutilized, oversubscribed cell. You're an enterprise, you probably have a dedicated one, or maybe multiple, right? And something in between. That's also a very often and very common pattern. Or you actually go and have critical customers in different cells. So if you have like 5 big customers, you have them in 5 different cells. So if you screw up one big customer is upset, not all 5 of them, right? So that's one. Or, for example, in internal systems, sometimes what you want to do, what we did in OCI, for example, was you separate the critical systems that depend on you so that they don't block each other, right? You figure out like what's the critical thing, and then you separate it so it does not break. How you build it in a cloud is also useful to know. Whatever works, right? So you can have availability zones. Each zone is a cell because that's where your service is, right? And maybe you do some clever application between regions and whatever, right? Or you have a cell that actually spends always an availability zone, so that cell is like strong. Or you have multiple cells in availability zones. It's really it really depends on what exactly you're doing. So now maybe what to avoid. What are the things that are like sharp edges in this? If you want to do this, you have to make sure that you don't share resources between cells. That kind of like defeats the purpose. At that point, if like more cells are tied to a certain resource, it means like, that's actually the one cell. Then the cell router itself, it should be really, really simple. The simpler, the better, because simple things are more reliable in general. If you put a lot of logic in the cell router, that becomes the bottleneck of a lot of things. A lot of cases started with not needing or saying like, oh, we are not going to migrate the customers' workloads in between cells because we don't need that. You realize that, oh, one cell becomes super hot and you need to move some customers out, right? Because otherwise, so it becomes actually very important to have the ability to move things between cells. And cloud is not limitless. They claim they are, but not. So it's good to figure out like what are the limits and size the cells based on these limits, right? Like there's a lot of limits. And for example, now working in Azure, like you go to subscription, There's a lot of limits. So maybe it's like you get one subscription per cell. So you make sure that you don't you don't grow too much. Dry is not always the best. Dry as in like do not repeat yourself, because here sometimes duplicating logic, duplicating the things in the cells is actually beneficial because you make sure that they are isolated fully. That's basically one of the main reasons why this is being adopted. Is it's really resilient to failures, right? Like you really like the idea now it's being presented as like, oh, the idea comes from the building ships where you have these separating containers. So like if there's a hole in the ship, it's just one part. Like everything works, everything else floats still fine. That's the idea. This works the same way here, right? Now, some people may ask like, oh, this sounds like a bit of like microservices thing, or like what's the relation? I think it differs. It differs a lot. And I think the microservices are possibly an implementation detail for the cells, right? The major thing is that the cell is like self-contained thing. It's not independent service. It's like whatever cell constitutes. It could be a bunch of services, right? It's a group of services, basically. In microservices world, you focus on the service as individual thing. It's not the group of things. Isolation in cells has to be full. Like you run it on different infrastructure ideally. So there's no correlation on failures, etc. In microservices, it's more about functionality, right? So you're fine if you're running on the same cluster, for example. Communication, like in between the cells, very rare, if any. You can do it, probably not very little. In the microservices world, you get service mesh and everything talks to each other all the time. Scaling, it's like, again, you scale cells and then you scale within the cells. With the services, it's like you try to scale the service, that's it, not more. And I guess that's the end of it. You get the fault isolation. That's the major purpose is resilience and isolation. And at scale, it becomes also easier to maintain. With microservices, it like the major focus, I guess, is the development, right? Like you ship fast, you're not depending on any other. You don't have to have like coordinate a lot with others. So, any questions? I think I wanted to make it an introduction, not really deep dive.